or the next page or the next section. This time we're looking at the area of a sector, so again it's a new formula. Last year we would have used these ones. We're now simplifying that to one single formula that we can use for area of a sector, where we don't have to do it as a fraction of the circle, but our angle does have to be in radians. Okay, so the first few exercises are simple formula plugging. So if we're trying to find the area using that formula, A equals half r squared theta. So we get a half times 4 squared times 2, which gives us 16. Number 2, same formula. But this time we've got our angle obviously in degrees, so before I start I need to convert it into radians. So it's 234 times pi over 180. Which we'll just leave actually like that. Okay, so now let's use our formula. So the area equals a half times 2.4 squared times 234 pi over 180. If we evaluate that, we'll get 11.8 centimetres squared. Obviously, at any point, if you're unsure about your calculation techniques, you should pause the recording and actually check that you get that recording when you plug it into your calculator. Okay, if we have a look at this one, we're trying to find the area of this rather large segment, not the small bit that's been taken out, then, sector. Then what we are looking at here is, if this is pi over 3, the bit that's been taken out, we know that the whole circle, from the work we did on radians, the whole circle 360 degrees is 2 pi radians. So therefore I know that this angle in here, the bit that still remains, must be 2 pi minus pi upon 3. Which equals 5 pi upon 3. So the area of the large sector is going to be a half times 2 squared times 5 pi upon 3. Now obviously 10 pi upon 3 is more accurate. You can leave it as that. But if we did want to calculate it as a decimal value, we could. But remember that if it asks for an exact answer, then you would leave it as 10 pi upon 3. Example 2. We've got different unknowns this time, so we're using the same formula but with a different unknown. So this time we're trying to find the angle. We know that the area equals 34 and the radius equals 8. So if we have the area equals half r squared theta, so if we rearrange that, we end up with 34 times 2 divided by 8 squared equals theta. So theta equals 1.0625. We tend not to put units down if we're working in radians. The assumption is radians if there is nothing written there, and we must write degrees if we're working in degrees. Okay, this time it's the radius that's unknown. Centre angle is 248, but of course we need to convert that, so we're going to convert it into radians before I start. and we know that the area equals 55.9. So we get 55.9 equals a half r squared times 248 pi over 180. So 55.9 equals 248 pi over 360 r squared. .9 times 360 divide by 248 pi and square root, giving me 5.08 meters. This time we know that the radius is 68, the area equals 1.04, and the angle is what we're trying to find. Notice it's in degrees, so you're going to have to highlight that for noticing later. Remember your exam technique, underlining key instructions. 1.04 equals a half times 68 squared theta. So 2.08 divided by 68 squared equals theta. It's in radians, so to do a conversion into degrees, times 180 over pi gives us 257.7 degrees. Example 3. Remember, these examples, as in all the handouts that we work through, have been chosen to specifically try and show you the things that you might encounter that are going to be problems. Okay, so all the different types of problems that you might encounter. Right, a sector has an arc length of 6 centimetres. So we know that the arc length is 6, and we know that the area is 9. We want to find the radius and the angle. Because we've got two different pieces of information which give us two different formulae, we'll end up with two unknowns with two equations, so we can solve it simultaneously. So we end up with one equation being 6 equals r theta, and the other equation being that 9 equals a half r squared theta. If we're trying to evaluate that, what we're going to have to do is think about being clever with your substitution. So if I take 1 and 2, if I say that I'm going to rewrite 2 as 9 equals a half r theta, we can see an r theta sitting there. So I'm now going to sub 1 into 2. And in place of r theta, I'm going to write 6. So we end up with r equaling 18 over 6. So r equals 3. And then carrying on with subbing r equals 3 into one of the equations. Let's choose equation 1 because it looks nice and easy. 6 equals 3 theta, so theta equals 2. Remember, good technique in simultaneous equations is to check your answers in the other equation and make sure that they do actually work. Okay, here we've got a triangle, which is unshaded, and a segment, which is shaded. And that's what makes up a sector. In a Cambridge question, what you would probably get is not parts 1 and 2, but you'd probably just get calculate the area of the shaded segment. So we're going to take you through the bits that you use along the way, but just remember that these building block parts are parts that you would have to work out the technique. Okay, so we know